Hey, what's happening, Daniel? Thank you for coming on today, man.
Hey, it's been a while.
I know, man. I know. We crossed paths working in pro sports when team I worked for got a HUMAC isokinetic testing machine, which was a game changer for us. And then we were just catching up. You know, my wife and I had almost moved back to Atlanta, so it would have been cool to reconnect in person more often. But hey, here we are still reconnecting cross country. But again, I am very much so looking forward to this chat with you because on a personal note, really want to revisit a lot of things you and I were discussing and working on the pro sports side, but also you have just a wealth of knowledge on like a lot of the nuances, and we've seen this resurgence of isokinetics and what it is and how it's meaningful. So have a ton of questions. I hope we get through them, maybe not. But without further ado, before we even jump into it, I always like to highlight kind of how you got to where you are, because a lot of young listeners want to either work in sports or integrate technology that you have access to. So could you briefly give us some insight into kind of your journey into physical therapy and ultimately what sparked your niche of
hmm
isokinetic testing and analysis?
Yeah, so thanks for having me on, first of all. So the funny thing is that physical therapy was actually my second career. I started off in the army shooting rockets out of tanks. And after a couple times around the planet, I decided I wanted to give this whole college thing a try. And being a meathead artilleryman, and I just really loved exercise. And so I decided to go, athletic training and then physical therapy. And I did all that at University of South Florida. And then when I was an athletic training student, we had a guest lecturer, John Hisamoto. He came in and he did a lecture on isokinetics. That was my junior year. So when it came time to pick rotations for my senior year, I was like, I want to go, learn from this guy. So did a rotation with him, and I learned so much from him outside of isokinetics. But the thing about isokinetics was he was doing stuff completely different than what we learned in the book and what you'd see in literature. So I saw this huge disconnect, and he even he admitted to it. He's like, "There's so many myths about what isokinetics is and what it actually can be." So a lot of my origin story really starts with him. So in the 1980s, not to date him too much, but when he came out of school in the early 80s, that's right when Kincom came out with their isokinetic system, and it had eccentrics, and it was the first one that had eccentrics. So he saw an opportunity to, really jump on that. So in the 80s and 90s, he worked with Chattanooga to help develop the eccentrics on the machine and also how to apply it, right? The practical aspects. So right before I came on with him as an athletic training student, the machine that I work with and the company I work with right now, it's called CSMI. They own the HUMAC Norm. Well, they bought that from Cybex. And when they bought it from Cybex, they started making their own. And they previously were working with isokinetics before that. But so they approached John because they heard he was like, the guru. And they said, hey, can you kind of, help modernize this system with what you did with Chattanooga? And, John was kind of towards the end of his career, and he was coasting along, getting ready for retirement. So he presented me. I was an athletic training student at the time, and then I worked with him while in PT school. But he said, hey, here's an opportunity. If you want to, you can really work with these guys and help develop it, and you can become the next guru of isokinetics. So I jumped on it. And so essentially we started by just taking what John developed with eccentrics, with his use of passive exercise, passive motion setting, and isometrics, right? And kind of applied that to this machine, the HUMAC norm. But then we also said, well, all right, well, we have all these new things in rehab, right? Rate of torque development, deceleration training. We have all these dynamic feedbacks that the machine can do now. So how can we apply those rehab principles and just put it towards the machine? So that's kind of what we started doing. We said, okay, well, how can we test for rate of torque development? This is, this is 2009. So kind of well before that people really started talking about that. The world was still stuck. The rehab world was still stuck, and everything was all about the hip abductors at the time. The quad was bad, and open chain work was bad. So we were kind of developing that. Or all right, what is this long hold heavy isometrics that people are doing, and how can we actually use that on the machine for our tendinopathies, for our patellofemoral issues? How can we use these dynamic feedbacks and make the patient not just push and hold, but actually have to control? And, we figure out, hey, this is really beneficial in that early, post-op phase for total knees and ACLs to really get that quad to activate and get that control back. This is also when BFR was coming out. It's like, okay, well, how can we use BFR, that same principles on and combine it with the machine? So all these, new, I say new, nobody that's actually listening can see me throw up the finger quotes there. Nothing is new, right? It's just all the same concepts that, have been around that we applied to the machine, but it's new now just because we're finally putting it out to the world. We did a lot of courses it was a course. We'd have therapists from Hong Kong, all over Europe. They would come and they'd spend a week, a weekend. We would shut down the clinic, do a full 2-day course. And then they would spend part of the week with us seeing, what we were doing in action. And we were doing this, multiple times a year. And so we kind of did that. And then the two brothers from CSMI, they came to visit and said, hey, let's show us kind of what you guys are working on. And they were just like, well, look, this is really cool. And nobody else is really talking about all these other concepts. So at that time, they invited me to go to the NFL Combine. And so I did that. The first year was the year of all the quarterbacks like Andrew Luck, RG3. So that was my first year. And I did that until 2018. So it was 6 years, right? At the time, I didn't have a family, but everybody else who went there did. So I'd always kind of help either build the machines at the beginning of the week or help break them down at the end of the week. So then I was learning how to, install and, put these together. So when their main installer at CSMI, if he wasn't able to get somewhere because of a scheduling conflict, they'd ask me if I could go, hey, can you go install this machine and, teach them how to use it. So I kind of took on that role, here and there. But when COVID came around and at that point I had left the clinical world because my wife, she finished her fellowship and we had a young family. So I kind of left that world. And that was right when COVID hit. So it was their installer at that time had left. And so they're like, hey, can you, do more installs for us? And I said at the same time, well, why don't we just take all the stuff that we've been doing at John's clinic, informally with courses and actually make a course out of this? Because there's a huge disconnect between, what the machines can do in the textbooks and in the research versus all these other new things that they can do. We should actually teach people how to do this. So it kind of organically happened that, I became their clinical education director and I became their installer. So I've been doing that now. I've been their main installer since 2020. It's pretty cool because it allows me about 40 to 50 different trips a year. So it ends up being about one a week or so that, I'll fly in, I'll install the equipment. I'll get, about 3 or so hours hands-on training with the staff. It's all over the country. I've been, even when I go to Singapore every year and work with the students there at the university. I was just in Turkmenistan a couple of weeks ago. But it's mainly within the US, right? So it just happened organically that I've made this kind of role for myself and I've become the isokinetics guy with the HUMAC.
And you certainly have. You are the isokinetics guy. If you think HUMAC, you think Dan. There is no, they are not separate from one another. So man, there was one. I didn't realize that you started. I knew you were in the military, but I didn't know you were in that sector. So that explains how probably the engineering side of installing and you start getting into physics around isokinetics. And I'd be remiss if we even didn't just take a step back. And you and I are probably maybe well versed and understand what isokinetics are. But for those that maybe are coming out of school that perhaps, they talked about it, right? ACL return to play, we got to have limb symmetry index and we got to talk about that. But more from I think I love to break things down to physics and what it is. So first, let's just talk about an isokinetic versus an isometric, and then I'll let you kind of take it where it needs to go, but really talk about priorities of physics that are important
Hmm.
to understand when we compare isometrics and isokinetics. So let's create the foundation for everyone
Hmm.
first before we really double click on some nuances and how powerful this technology can be.
Yeah, certainly. So the one that everybody knows the best is just isotonic. So if you're on a knee extension machine at the gym, you load it with 100 pounds. It's always 100 pounds, right? But you can decide, if you put a little bit of force into it, it'll move slowly. But if you put more force into it, you can move it faster. So it's got a variable velocity, right? Then you have isometric. With that, there's no movement. You lock it in place. And there's a couple ways you can do it. You can either load it up to a certain, let's say I put 100 pounds on it and I just hold it there, right? And just keep it held in place. Or you can have it to where it's just not going to move. And then you're allowed to push as hard as you want into it. So then it does become a variable load, isometric versus, just, putting it and holding it, even though you could possibly go heavier, right? And then you have isokinetic. And in that, you're keeping the speed constant. So you can set it to, either slower speeds or faster speeds. And no matter how hard you push or pull into the device, it's going to stay at that same speed, but it allows for increases in torque, right? And we all have areas in the range of motion where we're stronger. And that usually comes down to like cross bridging in the muscle, is the muscle in a fully lengthened or in a shortened position? The lever arm, if you're really close to the axis of rotation versus farther away, right? The load can have mechanical advantage or disadvantage over you, right? So you're going to have areas in the range of motion where you're naturally stronger. And so with isokinetic, you're going to adapt to, I should say, the machine adapts because it's going to push on you as hard as you push on it. So where you're stronger in the range of motion, you have more force, but where you're weaker in the range, it gives you less, right? So everybody thinks about it purely just from those standpoints. But one of the major things I try to teach people is it's much deeper than that when you come to a neurologic level, right? So when I test somebody isometrically, right, you're getting the least amount of, I call it noise from a joint, right? You're keeping the position locked in place. It's just, hey, quadriceps or whatever muscle, quadriceps contract and get a maximal load, right? Now you will get some feedback from your system. If you have pain, and let's say you have a patellofemoral issue, right? And if you're getting pain, you're not going to be able to push quite as hard. You are getting some joint mechanoreceptors. You are getting some loading of the graft, right? If it's like an ACL. But when everything is just kept standing still with isometric, you're getting the least amount of feedback coming back into your brain from that joint. Now, when you then switch to isokinetic, right, now you're bringing a lot more into it because now you're bringing movement of the joint. You're bringing in a lot more mechanoreceptors. You're bringing any graft site loading, right? If it's like a quad tendon graft, or if it's a total knee, or if it's a rotator cuff, right? You're loading that tissue. It's either being stretched or it's being shortened based on concentric or eccentric. You're getting a lot more neurologic inputs because I'm either having to accelerate with it or fight against it if it's like an eccentric. So it's a lot more than just the physics and how much load at different points in the range of motion. When you go to isokinetic, especially if you get to the advanced isokinetic where it's concentric and eccentric, you're getting a lot more noise from that joint that could possibly expose different weaknesses. So I would say, if you test somebody isometrically, it's kind of like getting an X-ray, right? It's going to give you some detail to what's going on, but you're missing a lot, right? When you go to the isokinetic, that's kind of like getting your MRI. It's going to uncover a lot more tissues, or it's going to expose torque, torque deficits in a greater amount that you wouldn't pick up with just an isometric. And even that, when you go to the advanced testing and you can do concentric and eccentric, because the standard testing, you're looking at concentrics only. You're pushing up into the machine with your quad on the way up, and then you're pulling down with your hamstring on the way down. But unfortunately, that's not how we, work when we're making a change of direction or landing a jump. We're mainly using eccentrics. And so I've seen it before where people are only using concentric because that's kind of the standard way. And then, you can test somebody and it might show, let's say they have a 15% difference side to side when you look at the concentric. But then if you look at their eccentric, it might be up to, 25 or 30%, because you're getting just a lot more, at that point, it's a lot more neurologic. The tissues are being stretched under load. So there's just a lot more going on with it that you wouldn't have uncovered if you had only done an isometric test, or if you'd only done, a standard concentric isokinetic test. So at each phase of testing, you're really exposing different things. And you can even do isotonic testing as well, to where, I set up a certain load. Let's say I can, find out what your maximum lift is, right? And I put you at 20% of that load. And now I'm asking you to accelerate that load through the range of motion. And our machines can measure, your velocity or your power outputs, right? So all these different ways that you test it, you can uncover different bits of data.
Man, that was brilliant. I appreciate you calling out more than just physics, and that's incredibly important. And you have taught me, and I've seen it in clinical practice. When you look at the force time curve, and we should probably talk about kind of the outputs we get from some of these reports relative to like a force time curve, but the shape of curves really is indicative of when you start talking about noise from the joint, right? You start to see that double peak, you start to see a dip in the rate. So, you did a great job highlighting the different types. And I appreciate you calling out isotonic too. I think I often forget to include that because I make the assumption that's what a lot of people are familiar with in their reference point. So I appreciate you including that as well. If we talk about, before we get into maybe some key metrics of it, how about we talk about kind of what the outputs are, right? And the reason when I say outputs, I mean, for those that are in the rehab space, performance space, sports science, something that's become a gold standard is a counter movement jump on force plates. And folks that utilize that technology and utilize that information can look at the graphs we get, the force time curves of the signatures of those movements. Similar to that, we can do the same thing on the isokinetic and isometric side and the eccentric side of things. So could you speak upon some of the outputs you get relative to visually before we even get into the numbers side of things?
Absolutely. And thank you for bringing up the force plates, because you can't see it behind me, but I also use a force plate system that looks at the functional side of things, because on the isokinetic machines, we're isolating each link. But I also believe that you have to look at the system as a whole with like a force plate. And then, I'm even looking into getting some like timing gates in this next year to look at, that aspect of it. Right. So the isokinetic is one piece of the puzzle. It's a pretty big piece, but it's not all or none like it used to be thought of, right? It's part of your decision making. So I'm glad that you brought that up. All right. So now to your question about the force time curve, things that we're looking at. If I'm looking at purely isometric, because I do isometric and isokinetic, right? I do one test isometrically that just they build up their maximum torque, and they have 5 seconds to build up to it. And on that, I'm just looking at, hey, how high can they get? How much force or torque can they put out? But then I also do a half second contraction for rate of torque development, because the HUMAC can give you, what is that rate of torque development? What is the torque at different timestamps? And on that, we're looking at, how vertical the line can be. So like on, the vertical axis, we have torque, right? So the higher or harder they push, the higher up our line's going to be. And then on the horizontal axis, we're going to have time. So the more torque they can put out and the faster they can do it, the more vertical that line's going to be. So if I have somebody with like after an ACL, and we'll see that they have, they're close in their torque output. It might be, 15 to 20% different. Ideally less than 10%, but we'll have a deficit there. But then when we zero in on that initial contraction, right, it'll give us a difference in foot-pounds per second, or if you're in the metric world, Newton meters per second. So it'll actually give you a visualization of how quickly they can contract, right? If we go to the isokinetic force curves, our system, it graphs it out with torque over the range of motion. So we get this, it's an ascending descending curve, because you're weak at the ends of the range of motion. So if my knee's bent at 90 degrees, that line's not going to be very high. But then when I get to mid range, we're going to see that line kind of curve up, and then it'll kind of curve back down as we near extension. So you can visually see, one limb versus the other, where, not just how much weaker they are, but where in the range it is. You can get some funky curves if somebody's getting like patellofemoral pain, and then you can get a dip, and it's kind of indicative. Usually, it's because the torque amount is more than the tissue is used to handling, so that pain signal from their joint kind of shuts down that torque output, and then they get past that point of that higher torque, so it returns. So we can visually see some things there. When somebody's having like a quad tendinopathy or a quad tendon pain or graft site pain, uh, as I mentioned with the isometric, where that line won't be quite as vertical, we'll see that there, that it's slower to generate that torque deeper in the range of motion. When we're looking at the eccentric side, some of the things that we naturally see is as the knee bends deeper in the range of motion, we'll see the two torque lines, diverge further apart. And that can be a few different reasons. One, they just haven't trained, in that range, or graft site with the quad tendons. If they have a lot of graft site pain, and as they're loading and that quad is being stretched, we'll see that torque diminish. But the lines will still be pretty steady. If we see, and I do see this a lot, is that the surgical limb eccentrically, it is not, it hasn't been trained neurologically to handle eccentrics under high loads. So instead of our lines being nice and straight, nice straight curve, or like a hill, like if you will, it'll be wavy, right? And you can visually see it happening in real time with their whole leg will shake. And it's all just because they haven't isolated that quadriceps through the entire range of motion under high loads. If they may have been working, the entire range of motion deep, but when you're loading eccentrically, right? If you're doing this, eccentrically, you should be 30% stronger at least compared to concentric, and that's across muscle groups, right? But if I'm only ever training with an isotonic format, and I'm lifting the exact same load eccentrically as I am concentrically, I'm never overloading the eccentric, right? Even if I'm on a knee extension machine, right? And I'm lifting 100 pounds up and then 100 pounds down, right? So I'm never really challenging that. Now, there are ways around that. You can always load heavier than that one leg can do concentric and lift it up with two legs and then, lower down with one. That's kind of the way that most people will do it. Or if it's a hamstring, right? People will do Nordics, and that's a really good way to overload the eccentric. But you don't ever really see anybody squatting heavier than they can concentrically lift the bar back up, unless they have two people there to assist them in the concentric. You see that a lot on bench press with the meatheads at the gym, where you put too much weight on for you, but you can lower it down and then your buddies help you lift it back up. But you really don't see people doing that with a squat nowadays. And even deadlifts, you'll see people, concentrically lift it up and then just, they might control it a little bit, but they'll just let that weight drop back down. So even if they are working through the range of motion, are they also isolating? Because if you're doing it in a squat or a Bulgarian or, a lunge, you're not just using the quad by itself. You're also getting assist from the glute max. You're getting assist from the hamstring. So it's really hard to really isolate those segments. So that will actually show up on our testing. That we'll do the test and we'll see their inability to hold torque eccentrically through the range of motion. Now, the nice thing about these machines is they don't just test, but they're also really good for interventions. So if it's one of my patients that I'm working with and we test them and we see that, we can actually work with them. If they're my patient, I've been working with them on it. But you can actually isolate each of those segments, overloading it eccentrically because the machine's going to adapt to them, overloading it through the range of motion because as that knee bends, it's going to allow for more torque output versus, on a knee extension machine at the gym, you've loaded 100 pounds, it's always 100 pounds. The cam system that they have on there kind of keeps it even versus, allowing it to get heavier as that knee is bent. So those are some of the visual things that we'll see on the graphs that are apart from the numbers.
I'm just sitting over here learning and nodding. That was absolutely fantastic. And I appreciate you calling out and talking about the eccentric side of it, because this question comes up a lot. And especially when you start talking about return to play, and I don't want to jump here. I want to just provide a little bit of context. Is it just for the listeners that understand the value of what Daniel just brought us, is that a lot of times we just focus on force production, force production, force production, the ability to move things, lift things, but the ability to control that true eccentric. And like you said, like we may think we're doing eccentrics, right? It was like, oh, go down for 5, lift up for 1. Like that's a classic. Oh, we're going to do long eccentrics today. The reality is if you can control it on the way down and still push it up, it's not the appropriate overload for eccentric. And you called out a number, and I would really love to just double click on this because I have learned 20% from isometric and eccentric strength in comparison to true concentric. I heard you say 30%. So I was really just curious if you could provide a little bit more in-depth context, even if there's some research you can point us to help us understand, hey, where are we learning that from a muscle contraction type, 30% eccentrically should be the standard in comparison to a concentric action?
Yeah, and hopefully we haven't lost too many people in the nerdiness of the conversation so far. So first, let me say with norms, right? The norms are, think of them as a bell-shaped curve. You're going to have some people that are right in line with what the research shows. And the research even itself is kind of all over the place. A lot of it is, it's so old because they tested it, 20 years ago, 30 years ago, and it was just kind of like, that's what it is. But then you look at a lot of other studies and it's completely different. And a lot of the really well-designed studies that I've seen lately only tell you the side-to-side difference or the LSI. And a lot of them won't report, torque to body weight, or they won't, look at, multiple elements of isometric versus isokinetic versus, eccentrics and concentrics. So it's a lot of just old foundational science that I really wish would kind of get retested in a modern way versus just, looking at only the side to side. Because then there's so much context around norms as well. So when it comes to, let's say I'm doing an isometric, right? I'm pushing against an immovable object. So 100% of my force output is getting pushed into that. So if it's on a dynamometer, it'll read that. Now, if that dynamometer is moving along with the same direction as the force, it's concentric, right? So you're going to be able to push less into that because now some of your force is being used to move along with the machine. And so if that machine, the isokinetic machine, is moving really slowly, a lot more of my force is going into the machine and less of it is being used to move along with the machine. But if I move it faster, now I'm going to get less force output because I'm moving. A lot of my force is just being spent to move along with the machine, right? So that's why you'll see like the force velocity spectrum that way. If you test somebody at a slower speed, and I just say slow because 60 degrees per second, that's what people consider slow, you're going to get a lot of force output with that. Versus if I'm testing you at 180 or 100 and 240. So the faster you go, the less force you're going to get with that. So the problem with that, some people will say that if you have a problem testing at 60 degrees per second because you have a patellofemoral issue, or just, I love Eric Maida. I've learned a lot from that guy, and he's all about tissue conditioning and load and tissue tolerance. So a lot of what I learned came from him as well, right? So a lot of people will test at a faster speed because that tissue is too painful to test at the slower speed because you can produce more torque and that tissue can't handle that torque, right? So they'll test and they'll say, oh, this is a better way to test. And I say, well, yeah, you're kind of putting a training wheel. I have 2 little kids, right? They still have training wheels on their bike. So you're kind of putting a training wheel on that test to allow them to test. The problem is that you're also putting a training wheel on that healthy side. So it's going to show that they're actually better side to side than they really are because I've put a training wheel on both limbs. I'm not letting that healthy limb show how hard it can push, whereas the other one's shutting down because of the pain. All right. So that's another topic. All right. So the faster I go concentrically, I can put less force out. So if I'm comparing an isometric which is 0 degrees per second versus 60 degrees per second of an isokinetic, you're going to get more force output from the isometric, right? Well, one of the problems is that a lot of our norms for like body weight come from isokinetic at 60 degrees per second. I haven't seen a study that takes a large group of people and tests them isometrically and see what they get and then test them at 60 degrees per second to see how much less it is. So when I'm looking at when I'm reporting, what normative is, I'm saying, if it's 100% body weight for concentric, I'm just saying it's 100 plus, because we really don't know. Um, I've had some people that go way above isometrically, and then you test them isokinetically, and they're even below a normative, right? Because again, there's more noise coming back in. So that's isometric versus concentric isokinetic. Now, if we look at the eccentric side of it, on this, I'm pushing against something that's pushing against me. So you're going to be able to put as much as you were able to isometrically, right? But now you're getting lengthening of your extensor mechanism if it's like the knee. So my passive structures like the tendon, it's going to be able to absorb some of that load and produce load into the dynamometer. You're also getting the tissues that hold the muscle together. I think it's the titin filament, right? It's also able to put contribute passive force. But then you also get a neurologic component as well, right? Everybody knows this from the stretch shortening cycle, right? When you stretch the tissue, you're activating the Golgi tendon organ and the muscle spindles, and they're going to increase their neural output. Well, you get the same thing occurring eccentrically, right? And the study that I use in my course, there's probably others that might say a little bit different, but if I take somebody in a concentric contraction at a given load and I measure their muscle output, and then I do the same load eccentrically, it's 70% less neurologic activity because you're more efficient, right? So you're going to be able to have more torque production just from the neurologic standpoint as well. Now, all of that adds up to about 30% more muscle output eccentrically versus concentric. I have some people that they'll put out 150% greater. I just tested a guy last week, and his hamstring, he was hitting like 151% eccentric to concentric ratio. And I was like, all right, you're good there. But if I see somebody, and let's say they push 100 pounds at their peak torque concentric, and they're only getting 100 pounds eccentric, well, that tells me that we need to make gains eccentrically, because you should be at least 30% stronger or close to it. Somebody's giving me, 25% over, that's close enough to that. But everybody's a little bit different. Some people will go well above that, especially if they've been trained and they've been doing a lot of eccentrics. If somebody comes in and they're testing at 6 months out and they really just kind of started getting into some of their plyometric work, they really haven't went against heavy loads yet, we'll see that be a little bit less. But if they come in at 9 months or 12 months for a test and they've done a lot of their high-speed deceleration work on the field or plyometrics, so they've been working with heavier loads, they've had more time to make those adaptations. It's one thing to challenge a muscle under a light load, right? Like you said, early in rehab, yeah, we're having them go down in 5 seconds but come up in 1. So yeah, you are challenging eccentric, but are you doing it at higher loads? And that's the thing. When we're testing on this equipment, we're doing it at max effort. When I have somebody on the force plates and, if I only have them jump at half their effort on a counter movement jump, I'm going to see pretty even side to side, right? Involved leg versus uninvolved leg, which one's contributing more. But if I then have them go to 100%, I'm going to see much more contribution from that uninvolved side, because now we're at that max effort load. And so that's the thing you have to understand. We're testing people at 6 months or so, usually for their ACL the first time, and they haven't seen max loads yet because it hasn't been safe to do max loads yet, right? So that's a long answer to the isometric versus concentric versus eccentric, right? Usually concentric will give you the least, isometric's in the middle, and eccentric is even more.
I appreciate the breadth of that, and you touched on a lot of points that, as you're talking about things, I'm just thinking about interventions. I'm thinking about how you start to connect. I love to hear you say earlier in the conversation talking about systems versus functional versus parts, right? Like they're all pieces to the puzzle. But what's interesting, and I hope we get to, like you said, I hope we get to some research that's able to utilize some more isokinetic. But I'd really love to see, like you talk about, we talk about force time curves, and we talk about that on the HUMAC, an isokinetic test or an isometric test, I'd love to start to see some relationships, with some functional
Hmm.
isometric tests, right? Like we talk about, the easily accessible force plates now. You start looking at isometric mid thigh pulls, IMTPs. We start looking at, single leg stance positions. How do these force time curves relate to what we're seeing in the isokinetic side? Like I would love for us to be able to say, yeah, like when we see, let's just say we see this curve and we see this rate of force development on an isokinetic for
Hmm.
a knee, and then we look into, hey, what does it look like in the whole task strategy of IMTP or a single leg stance? Like, how are they relating, and what relationship are we trying to see? Like, I'm hopeful we get there, because that's ultimately how we should be looking at things. We should be seeing, okay, how is the part contributing to the whole, and vice versa, how is the whole contributing to the part? Because ultimately they
Hmm.
should be in sync in my mind. At least that makes sense. And maybe research will say, actually, no, like whole task is always going to be greater than part task, and so on and so forth. But there's just so much I want to click on. And I think the first part I want to go to is we were talking about the rate of force development, which is important. I have not had the opportunity to look at it all that much in my practice relative to isokinetics. So I'd love for you to speak on more the rate of force development side, because you've
Hmm.
done a fantastic job highlighting the concentric, the eccentric, the isokinetic versus the isometric, but how that rate of force development becomes actionable, right?
Hmm.
Because we talk about, I heard you talk about, return to play criteria. And we often look at limb symmetry index, and we often look at, the con side, but we're not looking at the eccentric. I think we're starting to see more of the eccentric be meaningful, but I'm still seeing the rate of force development lag behind those
Hmm.
two. So could you speak more on the RFD side as well?
Yeah. So that's something that we just added to the HUMAC this last year, was its ability to measure rate of torque development isometrically. So what it will do, it'll give us a couple measures. One is the uh, torque. It reads foot pounds per second from 20% of their maximum to 80% of their maximum. And if you look across different measuring systems, whether it's our machine, if it's like an inline dynamometer or a handheld dynamometer, one of the ways they try to standardize this is by getting rid of the bottom and top 20%. So the bottom 20%, that can be, our pad that we use here. It's a really good mix of being firm enough to not just absorb all that initial impact that when you push into it, but it's also soft enough to where it doesn't feel like you're pushing into a board. And I've seen people that they'll actually have them push into like a 2x4 or a 2x6, right? So it's a good mix of that, right? And it's not going to move versus when you're doing like an inline dynamometer, you're assuming your setup is perfect, right at the angle you want. When they kick into that strap, whatever is connecting the limb to that immovable object, usually a table or something, well, that strap is going to absorb load, right? And they're all going to absorb that load differently, right? If I'm doing it with a handheld dynamometer and I'm trying to, you absolutely do your best to try to, standardize it. But when that patient pushes up into that handheld dynamometer, you naturally have to push back against them, right? Or else they're going to just push into you, right? So by looking across systems, if you eliminate that bottom 20% of the force curve, that's kind of getting rid of the noise of just that system, that testing system, absorbing that initial impact. But then you also get rid of the top 20%, because if I push and I'm having them go for, over a second, right? Well, they're going to continue to build even more torque, right? So it kind of gets rid of that extra little bit that they get at the end. And it also gets rid of, again, the strap or the handheld, any feedback from them pushing, it recoiling back. So when you bring it to that, 20 to 80%, it's really giving you the best line of rate of torque development. Our system, it's going to measure it in foot pounds per second. And I always explain this to patients as, you got two cars, they're at a dead stop, right knee, left knee, and then they're going to take off. How fast can they take off in miles per hour? We're just reading foot pounds per second. And so we'll see a pretty big difference there when we're first testing people with it, because that's another neurologic component. is that, how quickly it can fire. And you're not going to get the ability to regain your rate of torque development until you've regained your ability to produce torque. You're also not going to be able to train for that at month 3 or month 4 of an ACL because you can't test for that yet. You can't explosively have somebody, jump off of a box if they're still just working on squatting to the box, right? So it naturally lags behind from just a pure neurologic standpoint and in a rehab timeline standpoint. So I'll have patients when I test them, it'll show just on an isometric. It might say that they have, for example, like a 15% deficit. But then when we get to the rate of torque development, it'll show, up to a 50% difference side to side. And they say, well, why is that so different? I'm like, well, you're only 6 months out. You haven't really done a lot of interventions to target that yet because you were working on all these other elements and it wouldn't have been safe to do that. But now that you're 6 months and you're catching up in your torque outputs, now that's when you can begin training those things. So it's good to be able to actually show them not just a torque output, but the speed of that torque, how fast they can train it. Especially if you test them at 6 months and then you test them again 2 or 3 months later, and they can see exactly how many foot-pounds per second or what percentage of increase that improved also. The way that we were kind of testing it before on the machine was, I would find out what their maximum isometric load was, and then I would load up isotonically 20, 30, and 40% of that, and then look at their velocity and power accelerating that load through the range of motion. So that was kind of like a proxy of looking at it. So I'm glad that we were able to bring that to the machine. I know all the researchers out there are happy that we brought that to the machine because beforehand they were having to look through the Excel file and at the sampling rate of 100 to 2000 hertz. You're looking through a lot of data. So I know they're very happy that they can just look at our report and we give them that number now.
That's
Yeah.
phenomenal because I do realize that was when I was using the HUMAC norm itself, like there wasn't a good. And I remember you saying that, like, guys, like I just don't have a good like this is a proxy. This is how we can do it. So that's fantastic. So here's what I would love to do is we've really done a good job laying the foundation, talking about nuances between different things. I kind of just want to throw some like hypothetical scenarios that you've probably seen the gamut of it, and just kind of I'm going to throw like some scenarios and say, hey, this is what I would expect and reasons why. Like in the first one I want to throw is the classic, person gets cleared, ACL, high school athlete gets returned, they clear return to play. Some of the criteria is like hop testing. They look like a lot of concentric exercise, and the feedback is when they get on the court, like, they still get some residual swelling here and there. We're talking 9, 10, 11 months out where you would expect swelling hopefully isn't an issue then. And then, the biggest complaint is, it's just that, have a tough time stopping, and really just that ability to change direction still hasn't come back yet. So based on that presentation and feedback that, a clinician may say or parent may say, what would you expect was what you would see from some outputs? And then where do you think the missing or the rate limit, I don't want to say what was missing, but almost like the rate limiter and why they're unable to do the things that they need to do athletically?
So the first thing I would look at is, do the isokinetic test, right? Find out, are they having a big eccentric shutdown? Meaning, is the muscle producing torque all the way through as the knee is bending? Are they able to increase their torque? And then how much is it? So if that curve continues to build up as their knee bends, hey, that's good. We've cleared that up. If if that torque curve wobbles or it just builds up and then stays flat, then we know, hey, we got to get the neurologic aspect of eccentrics going before we can build up torque. But let's assume that they've already had that, right? And it is straight. Well, how much are they producing, right? Are they getting near their body weight or more than their body weight? Again, if I'm supposed to put out 1 foot-pound of torque for my concentric for every pound I weigh, that'd be 100% body weight. Am I getting at least 30%? Or am I only getting like 10% more eccentrically? So that's one side of it, right? The other is that rate of torque development. They might have good torque, but are they able to access it? It's one thing to be able to build up your torque in a matter of 1 or 2 seconds, but how much do you actually have access to? So that's the other thing, is the rate of torque development, right? And then the other thing is, when you're running forward, you're accelerating your body with your hip, your knee, and your ankle. And if you look at like a horizontal hop, right, the knee is only contributing, I think 13% with the one study I looked at. The rest is coming from the ankle and the hip. But the knee's only contributing about 13% of that horizontal hop. But then when you have to land that horizontal hop, now the knee is contributing 65% of accepting that load and decelerating. So it usually comes down to, eccentric. Are they strong enough? Do they have the neurologic capacity to do it? And then on the rate of torque development, are they able to do it in the time frame that sports demands?
When you see that, and that's if that's the
Mm-hmm.
presentation you would expect, right? Then the question becomes, like, during the entire post-op rehab and return to play process, right? This gets into another scenario I want to throw at you is, you have an athlete that clinically they're looking good, they're hitting some concentric measures, their functional movements looking pretty
Mm-hmm.
good. We want to start, protocol says, hey, initiate running at 3 months.
Mm-hmm.
And that's all it says, or initiate running at 4 months, right? We talked about the extreme of not being able to stop and not being able to decelerate, and you highlighted some good things to look at. Now, if we take a step back and say, hey, like, how do we start to be more specific within those protocols to say, this is when we can start doing some return to training activity? So the scenario I would throw at you is you have, a young professional basketball player that has had an ACL injury, and let's just say complications, no major complications of meniscus to rule out any additional precautions we need. And so now we're just talking about, okay, when would we say, hey, the knee, I love you talking about the difference of the knee, the percentage of knee contribution, acceleration, and deceleration. Well, if we just start talking about the ability to accept load, whether that's low intensity running or low intensity jumping, folks might refer to this as, getting in an alter G and starting running, or getting and start doing some extensive plyometrics just to increase impact. What might be, rather than saying, hey, here's a problem, how do we fix it? What can we say is, hey, here's our current status, we are now able to do X. How would you approach kind of some of those middle phases that everyone wants the secret sauce to and know when it's safe and how we can really hold ourselves accountable to progress or regress?
So what I found is that because I've also been at clinics where I didn't have isokinetic equipment to test, right? If you don't get the solid foundation of strength back before you start the higher level functions, your body is going to find a way to produce, you're going to find a way to learn to land, to jump, even if you have a quad deficit. There's tons of research that shows that you can pass a hop test before you actually regain your strength back. This is one of the big things I loved with, I went to Eric Maida's course. He has this great video showing a robot AI. And if you injure that robot, it's going to find a way to continue to walk and move, right? And it adapts based on the limitations you give it. And so if I start somebody jumping too soon or multi-directional stuff too soon, before I've restored enough quad strength to be able to do that task the right way, I'm just going to learn to do that task without it. And then you go through those natural progressions of, okay, and well, now we're making it even harder. And now we're on to return to sport, but we've never restored the element that is missing, quad strength. So the problem is, it's one of those things where if you could turn back time, we would have, maybe delayed that for another month and just worked on getting more strength back first. So if you're able to test along the way, you're able to find out, and whether it's on our machine or a handheld or a 10 deck, right? I'm not telling you that isokinetic is the only way to test, because you have more options now, right? So if you do have the ability to test along the, at month 2, at month 3, at month 4, and you're seeing that their torque output isn't increasing, right? Well, you can't just say, well, now you're 4 months, so you got to start running. Or now you're 5 months, or 4 months, so we got to start jumping. But your knee, the quad isn't getting stronger. So it's not going to be able to absorb that load. So the knee is going to stay a little bit irritated. But that little bit of irritation is going to inhibit it from continuing to get stronger. Right. And so it's really, it's hard to do, but you kind of have to pull back and, notice, hey, we really got to get you the ability to accept that load with your quad. And if you're able to test along the rehab, it's much easier to do. If you don't, and you're waiting until 6 months to get that first test, you don't know that they haven't been getting quad strength. Everything else is getting stronger. Their hip is getting stronger. They're using that. By not having that, then you're truly going on symptoms. And a lot of times, even just a little bit of symptoms every time you do it. But if you're doing that multiple times a week, that knee's going to stay at a low level of irritation, and that's going to inhibit it from continue to be able to get stronger. Right. So the biggest thing is find a way to test. If you don't have a machine, right, but somebody in town who does, you can send them there to get, tested. Doesn't need to be every 2 weeks or every month, but, test them out at month 4, at month 5, at month 6. If you have, a handheld dynamometer, or if you have an inline dynamometer, test them, because getting numbers, so long as you're doing the same setup and you're consistent with your setup, you're going to be able to track how they're doing. And you can actually see when they're making those improvements, when they're getting the stall, right? A lot of our athletes are going to naturally kind of stall out a little bit around month 4, month 5 with their strength, right? See, when identifying that, hey, we're in a little bit of a stall, right? We can't just go right into that single leg jumping, right? We're doing good with double leg, but you kind of stop gaining strength. So we can't progress you until we start getting that strength to come back up. And there's no way to know that unless you're testing, or you just have an athlete that's really good at letting you know how the symptoms are and listening to their symptoms.
I want to throw out a framework that I've just loosely working with, as far as, the question of, hey, when can we start doing some running, and when can we start doing some jumping? Because you did a fantastic job highlighting how that low level irritation, it's a double-edged sword. It's almost like, hey, sometimes we need to accept that that's part of the process, but when it lingers, right, that pain and swelling is actually inhibiting the one thing we're trying to improve. So if that constantly exists because of the impact, then that's where we just get in this rat race of not really ever being able to address the root cause. So where I've come to terms and have just had success, when you start just looking, and we're specifically talking about knees, and specifically talking about, impact, that being running and jumping. My general rule is, and I agree with you wholeheartedly. I think, as in my experience, on the rehab side, we pride ourselves in the ability to get back to running and jumping, but we often miss how important the force side of things are, and not only from an isokinetic, but just lower body strength as well. I'm pretty strict on that, and feel it's important. And the reason I stick to that is that I continually have success with this as we get to running and jumping. And so where my mind goes is, I don't clear an athlete to return to running re-education. Running re-education meaning skipping, marching, sled jogging, so to speak, right? A little bit of resistance just to overload the force outputs. Until we're at minimum a 70% con from an isokinetic perspective. And then every 10% up until, so then from 80%, then I'll really start doing, okay, let's do a little bit of tempo runs. And then I don't touch anything high velocity until we're minimum 90% on the concentric and above 100 minimum on the eccentric side. Because I do believe in this, and please, like, I'm going to ask you to pick me apart and tell me where I'm potentially right and what I'm missing. But I do believe you still get some of that training quality when you allow those activities to go, to be able to participate in. So I do believe you'll still continue to improve the concentric and eccentric as you increase high velocity activities. Not saying you still don't address the part task. So from like a running perspective, that's where I'm at. And then kind of falling in line similarly with some sort of plyometrics and jumping is at that 70% is where we just start to do some of our aerobic and extensive work. 80% is maybe we're getting into more intensive like box jumps, right, to minimize the eccentric side. And then once we get 90%, now we're really talking, okay, let's go for our more hurdle hops and intensive jumps and rebound jumps. That's where I've had success. Now, maybe I'm too slow. maybe I'm missing. I certainly have missed the rate of force, the rate of torque. It just hasn't been something I've had access to. So I imagine that's probably more indicative for some higher velocity sprint work or intensive work would maybe be beneficial, especially on the deceleration side. But to provide some practicality, right? That question always becomes, well, when can I start doing some running
Mm-hmm.
stuff or jumping stuff? As I lay out that framework, I would just love your perspective and insights as to what you think about it, because ultimately that's what we're all here to do, is like walk away with some practicality as far as, hey, what framework should I be leaning into? Because like you said, the research is 30 to 40 years old, access to this equipment, not everybody has 50, 60,
Mm-hmm.
70K to throw around for isokinetic machines. So would really love your insights into some sort of practical framework so folks can kind of work with that as they include some things like this in their practice.
So the numbers you just threw out are right on, by the way.
Okay.
Oh, that was perfect. So the only thing I would add to that is, um, you don't see it as much nowadays because we're in this really strange time where, I mean, when I graduated athletic training in 2009, it was 12 months return to sport ACL. And then we were trying to see, can we do it in 9 and 7, 6, 5 months, right? And the answer was no. But it's swinging back toward that like 12-month now, right? Um, so you want to look at that side to side difference, but there's so much variety in did that person have good strength in that uninvolved limb to begin with? If you're looking at high level athletics, they probably did. If you're looking at high school, which is most of the ACLs people are going to run into, right? You can get a really athletic soccer player, or you can get a soccer player who just played because their friends play, right? And they're not very athletic. So I also try to look at percentage of body weight, because
And
if I
let me
have
be clear.
30% difference side to side, but that uninvolved leg is stupid strong, right? If they're 30% above what the normal is because their strength was high before they got injured and they've kept their strength high, well, then we might be holding them back a little bit too long, right? Because we're comparing them to an overly strong limb, right? On the flip side of that, if I have somebody that has a stupid weak leg, like, if I want 100% body weight and their uninvolved side is only at 70% because they just weren't very athletic before they got injured, and then just with the shutdown and that crosstalk of being inhibited, their other leg hasn't, it lost a lot of strength, which you do see. It's not as common, but you do see that too. Well, then it's going to show that they're hitting 30% strength side to side earlier on, right? So if you there's one study I like to use that looks at jogging. When a person, they took subjects and they had them start a jogging program, and they also tested their strength isometrically. And those who could hit 48% of their body weight with their quad, and there wasn't a timestamp on it, it was just max output torque, they're the ones that didn't have pain and they didn't have gait alterations with jogging. But those that were less than that, those are the ones that had pain and dysfunction with running and also alter their gait mechanics. So I like to look at, are they within 30% of the other limb, but are they hitting 50% of their body weight? And now that we can do rated torque development, I like to see, well, are they able to access 50% of that body weight? Our machine, it puts a timestamp at 200 and 400 milliseconds. So I like to see, can they hit 50% of their body weight within 200 milliseconds? That doesn't mean that they can't run if they're less than that, especially, if they were multi-ligament or they had a meniscus repair, a really bad bone bruise, or they had quad graft, or they had an LET procedure, right? Or they're just a larger mass individual, right? They might not be hitting those numbers, but I like how you called it running education. It doesn't mean that, hey, return to run, go run a 5K, right? There's so many little steps building up to it. And it doesn't mean that that person who's less than 50% of their body weight or has less than that 70% LSI can't run, or they can't do any of those elements. It just means that, hey, the moment that they start to feel symptoms, we got to hold them back, right? You just don't push through it. Versus if I have somebody that's above 50% body weight, 3 or 4 months, which I see often, or they're really good with that 70% LSI. If they start to have symptoms, it's like, okay, just let it recover and then go do it again. Versus like, if that person's really weak, they have that weak side to side difference. When they start to feel symptoms, whether it's just, like I said, skipping, marching, jogging in place, that very first step of their jogging program, they might be able to do those. But the moment that they start to feel that, we have to know, hey, this is the person that we have to pull back on. But then if you're able to also test them again every 2 weeks, if you have like a handheld or a 10 deck, or if you have, one of our machines, you should see that as they're in their jumping or their running program or their plyometric program, that they're continuing to build torque. Because if that torque for their quad is staying the same, but yet you're progressing them in the demands that you're making them do, it's not going to pan out at 6 months when now they're trying to get back on the field and they've just learned how to do these activities around a weak quad.
I'm going to call out, I hope we can get some funding for this research study, because this, I think, was what we're going to. I would love to see a return to running program utilizing some of the technology that is measuring like a 1080, a Dynaspeed, and you start doing like high velocity, right? Sprint training. The world of sprint coaches are phenomenal at understanding these metrics, right? If you want to improve acceleration, you can introduce a load up to 80% body weight to drop their, max velocity to 50%, right? Like very specific to improve top end speed. I would love to see this collaboration between, a company like 1080 or a Dynaspeed and, the Isokinetics. And we start talking about rehab is like, hey, once we're able to achieve, 70% on an isokinetic, whether that's 70% LSI and a combination of maybe 70% of body weight, this is the resistance that we need to be able to do from like a return to running, from like a force output, because we're starting to get there, and you get those force time curves on that type of equipment too, right? Because now you can really start to dose the amount of force that we're talking about, right? You and I we keep having conversations around force and torque, and we just recognize that underpins everything athletic. And that's what allows us to be able to accelerate fast, hit top speeds, and also on the flip side, decelerate and change direction from an eccentric side. Like this is how it all ties together. You talk about part task, whole task. Eccentric qualities correlate to deceleration abilities. Concentric qualities correlate to acceleration abilities. Well, now we start to tie in like the resisted running is like how like I have a big progression and phase of just resisted running. The ability to do a sled push, do a sled pull. I don't have access to, unfortunately, anymore, like a 1080 where I can really dose the amount of kilograms and measure top speed. But I'm just thinking, okay, we're going to start. Our goal is to put 2 times your body weight on the sled and your ability to just push this and pull this, right? Like that's kind of a loose standard I have is, hey, can you push 2 times your body weight? And what I've seen with success is that, let's call it bro science, is what really is an indication of like, okay, wow, they're really able to produce force in a horizontal vector with locomotion, with adequate knee strength. And that tends to correlate also when they hit that standard. That's also when I tend to see from a part task perspective on isokinetic, they're hitting upwards of 85, 90% of their body weight on a peak torque output too. So like these standards of tying into, like we're getting locomotion technology to measure this, everything that you're talking about, just I'm in agreement and learning a lot from you here. I would just say, I'm going to call it out. We need some funding to get some sort of collaboration here to start tying the part and the whole, because here's where we're at. Performance coaches really understand the whole task strategy side of things. The physical therapists and the athletic trainers really understand the part task strategies, and that's just a product of environment. Well, now we need to blend the two together to be able to really have this robust return to sport play criteria. And on the flip side, the one thing I think that we haven't talked about, which I would love to just double click on too, is just like in the non-rehab, non-injured athlete, what this information from isokinetic also gives us into performance capabilities, right? You talk about, a lot of performance coaches in the strength and conditioning world do a fantastic job profiling athletes on force plays, strength testing, change of direction, max sprint speed and acceleration. Well, if we layer in the information that you're gleaning from the technology, how does that stuff relate? And if you want to chase top end speed or you want to improve deceleration, but the reality is they're only sitting at 100% body weight at a local knee, like I don't care what you do from a deceleration, motor skill training, overload, like you got to get that part task to strengthen as well. So I'm just spitballing with you here now and kind of excited as I talk about it. It's like someone want to throw me a couple $100,000, I'll get the study up and running. But like, yeah, like it's just, that's where my mind goes, Daniel, after talking all about this. Like, how do we start to integrate the two sides together to enhance the return to play side, but also how can we all improve our ability to profile athletes as well?
Oh, certainly. And everything that you just mentioned, there are so many different ways that we can actually look at athletes now. It used to be isokinetic was the only way. right? But now we have force plates. Now we have accelerometers. Now we have timing gates, right? We have so many different ways that we can, analyze this. So, whenever I'm, talking to PTs about this, this isn't the end all be all for your return to sport. There's so much that goes into it nowadays. And there's so much just working with that athlete day in and day out that you've seen them go through the progressions, right? So it's part of the puzzle versus it used to be the, yes or no. Um, I would love to see how they all integrate together. Now, you mentioned earlier if screening athletes, right? Um, one of the downsides is if you're trying to run an entire football team or a basketball team through all these, it does take time. If you can easily have them go on a force plate system and have them jump, it's over real fast, and do that every week. Takes longer time if you're going to set them up and do like an isometric test for both muscles or an isokinetic test, right? So there is the challenge of it takes more time than it does to have them to stand on the platform and do a jump every week. But I would say, if you're screening these athletes for performance and you test them out and you can see, okay, what numbers are you generating, right, relative to your body weight? Because if you're not injured, you should be close side to side. If something stands out, like, hey, you have a 20% difference, like that's something you need to clear up. But let's just say, assuming that you don't have any side to side differences, all right, well, how much force are you putting out, right? Are you close to that just normal athlete or, normal human metric? Or are you on, we want you to be higher up than that. So if you have somebody that's just sitting at the average, well, you're supposed to be a high level athlete. So if we can increase your torque outputs by 20% and get you to that higher level athlete, is that going to translate over? If I notice that, you're having an eccentric is weaker relative to what it should be relative to your concentric, is that something that we can improve upon and improve your performance? If you have the muscle ratio, the hamstring to quad ratio, there's some sports where, like basketball, right? You don't want super big, strong, heavy guys because they're twitchy. They're so tendinous, right? So a lot of their performance might not come from building up their torque outputs. But if they're sitting at like lower numbers and they're like a moderate level athlete, if you can build that up and then also you see the improvements on all your other things that you're measuring with like the accelerometers, with the force plates, they're seeing an improvement on the actual sport. That's something different. So it's more just you're uncovering and exposing things that you might be able to improve upon.
Absolutely. Absolutely. I love hearing you just describe it as like, can we improve the ability to be an athlete? And I appreciate you calling out that, not every sport is going to be the same. Like, I think we've seen that, and we can all think about, what you need for an offensive lineman is not what you need for, a left back in soccer. Which leads me to my final question, or topic that I want to hash out with you here. And let me just lay a little bit of context here and perspective, right? There's been a lot of investment going into research around ACL injuries in the female athlete. I think recently over the last 12 months, I've seen a massive initiative. I forget which European governing body on football has committed X amount of millions of dollars into the research around the female athletes and the occurrence of ACL injuries. And for those that are unfamiliar with why there's a prevalence, there are some theories and perspectives on that. Well, there's anatomical differences from the sake of, potentially a wider pelvis in the female in comparison to the male. Not always true, but more times than not, that is a normal consideration. There's also biomechanical influences that have come into literature from, moments of valgus and then from muscle activation and muscle strength, where do the glutes come into play? So there's a lot of information that is available, yet there's still a high occurrence of ACLs in the females, generally speaking, in comparison to the males, hence the investments from some of these large governing bodies. So one perspective I have on this is less about that there is a true difference in the mechanisms and more so the availability of good training and measuring access to the female athlete. And the reason I say that is if we were to apply the same training programs or similar training programs at the intensities that a lot of the male athletes undergo, would the hypothesis still hold true that females are still predisposed to increased likelihood of ACL? So I bring this perspective, and my question, stems around the differences, men versus women. Are you upholding the standards the same?
Mm-hmm.
And also just your perspective on this conundrum or this debate. This I don't want to say conundrum, and I don't want to say a problem, but what it is of a higher prevalence of ACL tears in females in comparison to males, like your perspective as to why.
One of the perspectives I heard, and I can't say this is right or wrong, is that traditionally a lot of females, when they're younger, they're not exposed to sports as much. But then you also look at it, it's like, well, you have high level college and professional athletes who are female and they're still tearing, right? So I don't know how much that theory pans out, because if that were the case, they wouldn't have made it to these higher levels of sport and still be tearing at higher amounts. I know I have two little girls, and we put them in karate and ballet because if I'm supposed to be this ACL guy, and if I can prevent my girls from having to go through that by just having them learn how to move before they begin playing true sports like soccer and basketball, I'm at least doing my part on, from my family's perspective. I think the answer is screening, right? If you can test them with force plates in an isokinetic machine and find the ones that are at the risk and then do something about that, can you then reduce that? It'd be one thing if we just tested, all the soccer players at a college or all the females at a college and then found out who tore and who didn't, and then look at the data later on and be like, oh yeah, well, they had weaker outputs. Well, that really doesn't answer the problems. Like that. The whole thing with it is, okay, well, let's identify those, see if we can do something about it, and then reduce the rate. But at that point, you've kind of skewed your data on that initial finding, those who were weaker if they tore. So it's really hard to measure because that's so much that goes into it. Because you might have somebody that has really high torque, outputs, really high strength, really high athleticism, but they're put into a situation on the field. If you get tackled, slide tackled, and just the way it happened, it doesn't matter how strong you were. Something's going to tear, right? So I think the biggest thing is just screening. If you can, whether it's with an isokinetic machine, if you don't have access to that, can you get a Tyndec? Can you get a handheld dynamometer? And then, find out, try to identify those who are at the higher risk and then, do something about it. Just, try to prevent that tear. My whole business model here in Atlanta is I'm a testing facility for all the local clinics. And I want them to send me their ACL so I can identify those who still have the strength weakness. I love it when I find somebody that's, at 7 months and they're really like their numbers look great, right? I'm glad because then I know that person can go back to the sport and have confidence with it. But I'm really wanting to find the ones that are still showing a 50% deficit at 6 months because I'm seeing that a lot here, right? Because I know that, hey, that person now knows I'm not ready to get back on the field yet. I still need to spend, another 2 to 4 months of strengthening before I get into that. Because if I go out and start playing today at 6 months, I'm at a really high risk, right? So it's taking your healthy athletes, finding a way of screening them, and then doing something about it.
Is there a perspective, we talked about some guidelines as far as normative values, albeit, there is a bell curve. Are you noticing with the high volume of, knee, particular ACL, any differences between, males and females? And should the standards be different, or is it fair to say, there should be a blanket standard across both?
Our norms are a double-edged sword, right? So just for quad output, the norm is for males 1 foot-pound of torque for every pound you weigh, so 100% of your body weight if you're using the US system. But for females, the standard that a lot of research shows is like 80 to 90%, right? Which if I have a female and she's 5 months out of her ACL and she's hitting 90% of her body weight at 5 months out, that doesn't mean she's ready to go back, because that just means that she's probably going to be on the upper end of that. Because I have some females that are hitting, 130, 140% of their body weight, which is way above like the male standard, right? But if we say, okay, well, you've got symmetry and you're 80% of your body weight and you're at 5 months out, that doesn't mean that they've reached their capacity yet, right? But on the other end, if I have somebody and I test them at 7 months and I'm looking at that side to side symmetry and their uninvolved leg is only at 80%. And let's say they're 20% weaker on their surgical side. And then I test them again 2 or 3 months later, right? And I see that their surgical side got better, but that uninvolved side's not much over that 80%. Well, I know that, hey, that is the norm for them, right? Because it's later on. They've had a chance to go through true strength and conditioning, and their norm truly is 90% of their body weight for their quad. So it's the timing. If they're only 5 months out and they're at that standard, well, they still have time to get stronger because they haven't even really gotten into true strength and conditioning yet. So, but if they're showing me that they're only at 90% of that and they're at 9 months or a year out, then I know, hey, that's probably more their standard. But again, like I said, I have females all the time that are way above the male standards for their torque outputs. But it also goes into what is their mass. If you have a male or a female, let's say I'm a male. Let's take the gender side out of it. Let's say I'm a male and I weigh 250 pounds and I'm just a larger mass athlete. My torque to body weight standard is going to be a little bit lower for that athlete versus, now you have an athlete and they weigh 200 pounds and they don't have an ounce of body fat on them, right? They're going to be well above that, 100%. There's so much context that goes into norms. What sport do they play? I recently had a young lady, her main sport is lacrosse, right? So lacrosse starts in January down in Georgia. So, but she was wanting to play softball, which is a fall sport. And, for her torque, it was less than what we wanted it to be for lacrosse. But for softball, I was like, look, I have no problems with you going out and playing. She had a really good symmetry. It was a little bit beyond 10%. She was, had close to normal body weight standards for males. But I told her, I was like, look, you can play softball this season, but you got to continue getting stronger. You need at least 1, maybe even 2 days of intense strength training. That way you're ready for January, right? So there's so much context that goes into return to sport. I've had an athlete that I worked with before. He was ACL, MCL rebuild, both meniscus had to get repaired. His only shot at going to college was getting a scholarship. And the season was starting. It was 7 months after his surgery. His numbers weren't where we wanted him to be. But I was like, look, if, him and his family, they were willing to roll the dice and possibly accept that higher risk, knowing that he might be able to get a scholarship out of it. So, but he didn't just go back to 100%. He started with practice, made sure he was good just doing practice and drills. Then he went to special teams, started doing special teams for a couple games, and then he started playing. He was a linebacker, right? He was a little bit slow on that first game, so they then moved him to defensive end, and he did phenomenal, right? But I mean, I was really nervous going into it, but he was willing to accept that risk. His surgeon understood the context of them, right? And it would have been different if it was his junior year. I'd be like, look, man, you might be able to play the second half of the season. Let's continue getting stronger. But it was his senior year, and that was his only chance. So again, context is everything. Every athlete's different.
Thank you for that story, because I had those conversations in the pro space where, you're talking an agent, a player, a GM, and a coach. And there seems to be a more understanding and like, okay, if they're not ready, they're not ready. Contracts come into play, playoffs come into play, all those things. Most of the time, I err on the side of, hey, give it more time, was my experience. But now being in the private space, the scenario you just played out and how you handled it was class act. And I just want to commend you on that, because I get a lot of questions from local practitioners being like, how do this kid, a lot of AAU basketball starting to roll around, and that season's starting to pick up out here in Scottsdale. And I got parents reaching out, hey, so-and-so's hurt. Like, how do I manage this? How do I get them to play? And, well, what year are you in? Are you a sophomore? Are you a junior? Is there, just consulted and had a 5-star recruit, he's a junior, and I got, all these offers on the table, but, knee is still problematic from a surgery 12 months ago. It's like, well, okay, like what's meaningful? How do you approach this situation? So there's so many contextual factors, and it sucks that you and I can't sit here and say, yeah, this is how you do it, which is what everybody wants. We just all want to, and especially those that don't understand this space. Most, you talk about parents, you talk about front office executives that may have not been able to play at a high level, who have only been around it but never endured it, right? So then it's very difficult to understand if you've never existed in this space or played it. So I just really commend you on how you handled that. It's a very real situation that happens for a lot of parents, a lot of practitioners, a lot of coaches, and you highlighting that it's all contextual and you have to consider the relative risk. Ultimately, we as providers are to provide. Our goal is to ensure safety and provide adequate recommendations rooted in good science, good medicine, and good practicality, good application. But ultimately, like you said, it was the athlete and family's decision, and because they were trying to get this scholarship in the senior year, right? I thought you just brilliant example to close this conversation out of a real life example that happens more often than not.
Yeah, absolutely.
Man, the final question that we always got to ask here on the show is, we're all about trying to just maintain success and high performance. And you've clearly highlighted how we can do that in the rehab space, clearly highlighted how that can be applied in the return to play perspective. So with all the experience you've had within the isokinetic world, your rehab, even dating back to your military days, right? For those that, want to continue to improve, find their small wins to continually move forward. What advice do you have for folks that want to make small upgrades to their health and performance?
Look for opportunities, right? Know when to say yes, but also know when to say no. That's big. There's so many opportunities within our field that if you see a hole or you see something, a need that needs to be filled, try to find your way into that. Get a hold of people that are that expert, right? Physical therapists, athletic trainers, we tend to be very altruistic, want to help people. So, make somebody tell you no, right? If they want to get into basketball, like I know people who are in NBA, but, find that person who is in there and try to make connections with them. If you want to get into pediatrics, cardio, whatever it is you want to get into, if you don't see an opportunity locally, you might have to relocate to get to that. So it's about finding the opportunities and then really taking advantage of it.
I appreciate that, man. That's brilliant advice, and I hope those that are listening take that to heart, because it's coming from a deep place, and I recognize the career you've had and the people you know. So coming from you, it means a lot to me personally. So I hope those that are listening have the same perspective. So hey, man, this was an absolute masterclass on all things isokinetics, isometrics, breaking things down. So you crushed it. I know our listeners are going to gain a crap ton of information from you here. But you also, you're clinical director of education for CSMI for the HUMAC Norm. So you have your own course as well, even jumping into more of the research and application for topics related to isokinetics and return to sport. So we'd love to just highlight that and point people in the right direction to learn more from you.
Yeah, you can find that at the humacnorm.com. We have a free mini course we call it the Isokinetics 101 for the classroom. We just basically took my 7-hour course and condensed it to an hour and a half. So it was kind of like a little mini course. We also have the full CEU course. It's also on our website. It's just called Isokinetics 101. I do live courses also. If anybody ever wants, anything with that, they can always get a hold of me. But then I'm pretty active on Instagram. My Instagram is my clinic name, actually. It's a Proactive Athletic Performance. And it's, I just post, treatments that I'm doing, tests that I'm doing when I'm, at different locations doing installs. And that's actually probably the easiest way to people get a hold of me is just, DM me on Instagram. Or if they want to email me directly, you can use my CSMI web email. And that's just daniel.bodkin@csmisolutions.com.
Perfect, man. Well, make sure everyone slides into your DMs to learn all things isokinetic. And man, this was fantastic. I appreciate your time today.
Yeah, thanks, Adam.